So welcome back to the another lecture. So I have told you in the last class is that we have end up with that playlist of MATLAB simulation in DC to DC converter. Now we will move forward. That what is our plan? What next we will going to do? So this is only the thing I am going to discuss here. So you know that we have whatever simulations we have done, that is the analog control. We have not incorporate the digital. We have used the S domain controller. We have calculate the values in KP and KI. These are all in continuous domain, right? But if we want to improve our efficiency, if you want to improve our control strategy, we should go for the digital control. So digital control use the discrete things to do. So now when we use the controller, those are discrete controller. Now how to do the MATLAB simulation in the discrete domain, that we think we will going to see next. So we have end up with this, whatever the voltage mode control, current mode control we have done for the analog MATLAB simulation, the same thing we will do for the digital control. Because when you design the controller, if you know that if you use any PI controller, so how the PI controller, so controller in analog domain are basically designed using the op amp. So if you need, you maybe you know that this particular thing, R and then capacitor, right? So we have to, you know, this particular circuit. Okay, so if I want the PI controller, I need to do this particular thing. If I need my analog control, I have to took the values of this resistance and capacitance in such a way that I should come up with the desired value of the KP and KI. Because I know in analog domain what is my transfer function, KP plus KI by S, right? So I want to tune this particular value in such a way that I have come up with this KI by S, right? So, and what is the drawback? Once I have formed this op amp, I cannot change then further, because if I buy the resistance, buy the capacitance and take this particular KP plus KI by S, that is fixed. Now if I want to change my controller, I have to change the entire circuit. I have to change my resistance value, I have to change my capacitance value. This is the drawback in the analog control. But when you go for the digital control implementation, that time you don't have to do all this thing. You will buy one microcontroller or chip, you just program it, and once you program it, you can use it. And if you want to change it, you just have to change your program, just change the number, you will change your controller. So that is the thing we have to look for. So that is the advantage of digital control, and digital control is the right now very popular. So we will look the MATLAB simulations in the digital control. So I will create another playlist where we will see the MATLAB simulation in digital domain. Another thing what I am going to do is I will have planned to provide you the LT Spice simulations of DC to DC converter. So what is the issue now? Now we have done one totem pole PFC where we have used the what MOSFET, because we can't have the silicon carbide. But when you do the simulation in the LT Spice is a software, just kind of the where we can see the output voltage, distortion, everything. But we can use the practical devices with its parasitic value and all. So I can incorporate, I can use this particular switch here in LT Spice. So I will just download its footprint, I will just download its model and all, and I can use it in particular LT Spice and I can simulate it. So if you want to have better practical experiment, then you will go with the silicon carbide. Again, one more thing is we have done how we have generated the PWM and all, right? And that gate signal we have given, but we cannot give directly gate signal to our devices. We need to have one gate driver. Okay, what is gate driver and all, I will tell you in the later videos. So maybe you, if you know, that is good thing. So what is gate driver and all? So gate driver provide the signal with the protection. It will provide the protection also, and it will give the signal to our directly. We will not give duty ratio to our switches, so we will use the gate driver. This gate driver will generate the pulses and give it to you, but in MATLAB we can't provide the gate driver. But in LTSpice we can download the gate driver and we can connect in practical circuit and do the simulation. So in this way LTSpice work. So I am creating the another one playlist to do the simulation in the LTSpice. So hope so these two playlists will really help you. What I have learned, I will just try to give you that knowledge. So that's it for this video. So thank you all. So I will created the two playlists and hope so you will enjoy those two playlists. So digital control implementation I will start, and LTSpice simulations I will start. I will start the LTSpice simulation with the basics. So we will go from zero to some particular medium or advanced level, so that you have enough knowledge, then you can do the things by your own. So thank you, thanks.